Thank you all for joining us. I'm really excited to invite you to welcome you to this session that is 2 years in the making. As Naveen has mentioned at each of the prior sessions in this colloquium series, this began as conversations that we were having in the hallway, in which we began to appreciate similarities in the ways in which informaticists and medical educators approached questions like, how do people learn and how might technology support learning? How can learners be supported as they apply knowledge in clinical practice? How do we assess learners when they practice in complex care delivery systems where education is only one part of the mission? And as we continued those conversations, it became clear that medical educators and informaticists often share goals, but don't have so much knowledge of each other when it comes to the language that we speak or the concepts that inform our work or the methodology that we employ. And because of that, we saw that conversations, colloquia, might be helpful to bridge some of this gap. In our first session, Dr. Dan Schumacher from Cincinnati led us in an amazing kickoff, asking us to question paradigms built into how we approach our work. You know, is there only one truth to measure? Are there multiple ways to make sense of the world and clinical practice? And how should that inform our approach to medical education? How do we use the immense amount of data we have and we are able to generate to build a new transdisciplinary future for medical education? In our first panel, to build on these questions, Dr. Anna Weiss provided a historical understanding about how our conception of knowledge has evolved in medical education, posing questions about a 21st century where medical knowledge far outpaces what any trainee could possibly learn. Dr. Rebecca Tenney-Suaro introduced questions about how clinical reasoning develops and asked how technology might help learners identify areas for growth, questions that we're going to explore in a little bit more depth today. Dr. Evan Orenstein from Atlanta presented evidence that decision support systems can not only support clinical care, but also support learning at the same time. In our second panel, we explored knowledge application, specifically how we teach and support learners in their clinical practice. Dr. Jill Posner posed questions about how to balance teaching in a clinical learning environment and the need for data and the electronic health record to both focus and support teaching, particularly when it comes to decision-making and information synthesis. Dr. Maya Jawan from Cincinnati described electronic health record and bedside efforts to support trainee and team situational awareness around patients at risk for clinical deterioration, arguing that when patients deteriorate,
ended up doing some career development work. I got a career development award and ended up taking the implementation science course.
Can you just mute for a second?
With Renad Matus and Megan Legenfall and others over there. And
can you mute all and then unmute me? When arguing that when patient deterioration leads to a bad outcome under the care of a trainee, that represents system failure in terms of prediction, prevention, response, but also trainee education. Dr. Jeff Gold from Oregon presented his work improving clinical performance and error detection using electronic health record-based simulation training, focusing on effective use of electronic health record-based information. And so the aim of this series has been to engage in some of these conversations with a little bit of depth. And beyond just discussing the particular topics, we're hoping to form a community interested in this intersection. I want to invite you to sign up at dbhi.chop.edu to watch previous sessions and receive the invite to our final session on May 20th, in which we're going to reflect and consider how medical education and informatics might converge. If you didn't register for that upcoming session, you can go ahead and do so again. And I also wanted to note CME is available for today's sessions, and you'll receive an email today about how to claim credit at the email address we have from your registration. Um, Today, I'm thrilled and honored to welcome three panelists to continue this conversation, specifically focusing on assessment, how we assess learners, especially learners embedded into systems. Dr. Kate Clancy is an assistant professor of clinical medicine at Penn. She leads a new simulation-based program at Penn Medical School and is going to talk about assessment in the context of simulation. Dr. Brent Tama is an associate professor of emergency medicine at University of Saskatchewan, who's developed innovative EPA-based assessment dashboards and is going to talk about how he has used those to improve education and both for trainees and for educators. And Jonathan Ron, who's the CMIO and assistant professor of pediatrics at Boston Children's, is going to talk about bridging some clinical information and trainee information to, again, understand how we might evaluate and improve training and clinical practice. So with that, Hannah, I think we could start Kate Stock.
Hey, thanks so much for having me. My name is Kate Clancy. I'm an adult critical care and pulmonary physician at Penn and the Philly VA. I specialize in sarcoidosis and do work in medical education and technology. For my part today, I'm going to focus on assessment opportunities in simulation and in particular on technology enhanced simulation. And in doing so, discuss some major opportunities, of course, limitations, and future areas of growth and interest. I'm going to start out by touching on some terminology for simulation modalities and technology, just to get everyone on the same page. I'm going to talk about some existing paradigms for assessment of diagnostic reasoning and simulation. And lastly, briefly discuss some limitations and potential future developments, but I'm really excited to use that as a jumping off point for discussion later on in our session. So when you say simulation to a general medical educator or clinician, they're probably thinking first about in-lab simulation, our traditional method of practicing clinical cases in a lab with a mannequin or SP. In situ simulation is a variation, in my opinion, an improvement on in-lab simulation, as it brings the experience to the actual clinical environment and the actual clinical team. That's going to heighten the fidelity, especially by having people practice situations with the people they're really going to face them with. Technology enhanced simulation is an emerging field. Technically, a sim man or a sim baby, in your guys' case, fits this category, but there are three other general categories to know about. Virtual reality, that's going to be a computer-generated environment, which can be desktop or phone-based, partially immersive, or it can be headset-based, a fully immersive environment that includes often haptic or tactile feedback through the hand controllers. Augmented reality is really overlaid technology on top of a real clinical environment, and that's used mostly in procedure-based education or anatomy, and so we won't really spend much time on that today. Alternate reality and virtual reality overlap quite a bit. They're both computer generated, but in alternate reality, this is going to be something more like an EHR-based simulation. That's where that fits in, because it's a learner interacting with a constructed parallel environment that's responsive to their inputs. So all of these forms of simulation can be built into in lab, in situ, or distance-based simulation, which has become, of course, increasingly popular in the age of COVID. Before we get into the nitty gritty, I wanted to just take a 1,000-foot view and think about the purposes that we use sim for in education. We talked about team-based training, but of course simulation can be used as an assessment tool for summative feedback. This is what an OSCE is, right? So it's more often used, though, as an educational tool or practice environment where we provide formative feedback for the learner. But assessment's a part of this too, because in order to provide formative feedback, you need to tell the learner where they are, right, before you can tell them how to get better. Lastly, especially as these distance-based asynchronous simulation technologies become more accessible to people, we can start to conceptualize sim as an environment for deliberate practice and remediation. Before we get really into it, we'll do some light assessment theory just to ground our conversation. Most of you are going to be familiar with Miller's pyramid, which is the traditional version shown here on the left. You're either assessing what the learner knows, that whether they know how to do something, whether they can show you how to do something, or what they're actually doing. There's some newer versions of Miller's pyramid meant to address some of the limitations. So this implies a hierarchy. A segmented version that says, hey, maybe these things are all equal. These types of assessments are all equally important. The inverted triangle reflects that traditionally it was really hard to measure what the learner actually does. Now, with lots more data, including what y'all are doing in informatics, this actually becomes much more accessible here. Maybe this is the tip of the iceberg and everything else is underneath it. Nested theory is a similar idea, and this tells us that if we're looking at what someone does, isn't that implying that someone could show us how to do it, that they know how to do it, and that they know the foundational information? In many cases, yeah, that's true. But for the skeptics out there, there's this alternate conceptualization where, which is acknowledging the scenario in which someone can do something, and maybe they can show you how to do it, but they actually have no idea why it's that way or the medical knowledge underlying that. So this is the evolution of Miller's pyramid. We like to make things more complex in theory, but this is, I think, an example of when it actually makes a lot of sense. So let's look at this one more way, and this is the way that I think best ties back to simulation. And so one of the issues with assessment is that when we're talking especially about this does measurement type assessments, in a real world and in simulation, in many cases, when you're looking at what someone is doing, like what they accomplish, what the outcomes of the situation are, yeah, you're going to measure who this learner is, but you're also going to be looking at the performance of the team as a whole, and then, who is person B? What do they bring to the table? Who is person C? What do they bring to the table? You can also switch out person C for the EHR, for another element of the system. And so when we think about assessments, they line up with these nodes. And in most cases, simulation is going to fall into this area where we're really measuring, can the learner show us what to do? If the simulation is very good, very high fidelity, maybe we're that much closer to what they're actually doing. But really importantly here, this is the big opportunity, which is that in these technology-based simulations, as opposed to these in-person group simulations, you can fix this person. Like B is no longer another learner. They actually can be a computer-generated nurse that's going to act in an exact same way for all the different learners that encounter the scenario, or act in a certain way based on how the learner acts. Basically, with simulation, you have the opportunity to get closer to the individual's actual performance by fixing these other areas. So in general, like, what are we doing so far in simulation to make assessments? This is a great kind of initial survey study. It's a little old, but I think it still rings true for the most part. And basically, it's a systematic review of technology-enhanced simulation and the assessments that they reported on. And it's looking at what was the validity evidence for the assessments that they proposed and used in their studies, and then how did they report on those? And the overall spoiler alert for this paper is, we're not doing a good job here. And what they found was that people were, first of all, lots of variation in types of assessment being used. People very, very infrequently reported on validity evidence for the assessment tools that they made. And when they did, they often used this comparison to expert performance. That gives us construct validity. That is a useful way of building an assessment tool, but there's more to it than that. So let's talk about the case-specific assessment, which is most often what's used in simulation. And this is kind of grounded in this idea of critical action performance. So does the learner do the things they need to do for this case? These are often set by the case creators as they're building the case. So like, I'm building a case about an MI, I think that these are the critical actions you have to take. When this is done well, you get some construct validity out of that case creators because, hopefully they're experts or at least competent in those areas. But then when you actually bring the case, see how an expert performs, and do the expert's actions, the line and performance line up with what the creator set out, that's going to add some additional construct validity. At its simplest form, we're basically saying, does the learner get the right diagnosis, and do they start appropriate initial management? Most of the time, we're going to want to build additional complexity into the assessment and include in that process measures. So instead of just getting the right diagnosis, did they create a differential? Did they include key diagnoses that are kind of can't miss in the scenario? Did they prioritize the diagnoses appropriately, either verbally in writing or as implied through the actions that they took? You can look at the order or parsimony of questions or actions. This is where the expert comparison often will come into play. But you can also use things like for high value care simulations. You can look at things like, do the things that the learner order, do they align with guidelines, or do they align with criteria, say from the American College of Radiology for the situation at hand? And then of course, timeliness is going to be part of this as well. So, it's not enough in a code simulation to say this is a pulseless electrical activity arrest, but that in fact, we need to start CPR within 90 seconds of walking into the room. Another way to approach this is to start out with a theory and build your assessment off of that theory. And so the kind of most common one applied to simulation is situational awareness theory. And at its core, what it's getting at is that, does the learner or person interacting with the simulation perceive data in the environment? Do they comprehend it? Do they understand what it means? And how do they project that into future states? Of course, this will end up with them making a decision and performing an action that's measurable. And of course, there are system factors and individual factors that go into all elements of the process. This is a kind of well-trod theory and application going back decades, and the initial way of doing this and the most traditional way of doing it is that you actually pause the simulation and you ask the person, what are you seeing? How do you interpret it? And what does that mean about how this is going to move forward, how this scenario is going to unfold? You can also use things mostly for perception that look at clicks on the EHR, that look at eye movements to say, does this person see this thing? Or you can do things like listen in to how someone is running a scenario, if it's an emergency scenario, and saying, are they saying this? Have they verbalized that they saw this thing? Which is, that's not exact, right? Because you're not actually asking them. You're inferring it from other measures, but something that's been put to use. And then the group here at CHOP has put this into really good practice in the EHR-based simulations by basically building assessment tools, looking at when a learner interacts with the EHR, are they seeing the information? Are they perceiving the information from the EHR? Are they comprehending it? So like, do they build the right differential off of that data? Then finally, can they project that data? So do they make a decision that says, I'm going to send this patient to the ICU because I'm really worried about their clinical state? With the EHR-based data, you can fix things so that they're potentially getting kind of bad information or conflicting information that will then influence their perception, comprehension, and projection. So to wrap up, limitations and opportunities. So for now, and this is changing, but for now, when you're making a computer-generated simulation, you're still dealing with sort of fixed scaffolding logic that underlies it. So often when a learner is interacting with a simulation, they can't just kind of freewheel it. They need to come in. They're basically faced with choices. So you're faced with a menu of what do I ask, or what do I do, or what's available for me to order. And that's not quite how the real world works. We're moving into a space where we're able to use natural language processing to listen to the learner and then present them with some options. And that's getting closer, but it's still not that great, to be totally honest. Like, we're not quite there yet technology-wise, but that's where things are moving. And then opportunities-wise, so there's this adage that assessment drives learning. I just told you that many of our assessments are abysmal. And so that's really scary, right? So we need to bring this level of assessment up if it is true, and I believe it is, that's going to drive ultimately learning. And then this brings us to a question I couldn't help but ask in this really, really brilliant group of educators, informaticists, is that what do we do here, right? Because should we move assessments towards our current practice, like I described before, that like our simulations are built to kind of have this organization that's underlying it, and that's not really how things work in the real world right now? Or do we stay in this kind of checklist-oriented world, this menu oriented experience, because maybe clinical practice is moving towards that way anyway? Or if it's not, maybe that's the right way for it to be. And if assessment drives learning and practice, then maybe we move things that way. I don't know. I think it's something that's really up for debate. But I'd love to hear your all's opinion about that. And finally, I'll wrap it up there, but I just want to thank you all for your attention. And I'll leave you with this very staged picture of me using a VR headset. So I'm excited to hear the rest of the panel and to discuss with you all. Thank you.
I love that picture, Kate. I kind of wish it was back up here. We'll have time after all three presentations to discuss together. But I am thinking about your last slide and some of the questions that you pose. And simulation is a strategy that we also use in informatics just as a form of usability testing. Like, does the thing that we build, how do people use it? How do they make sense? Does it make sense out of my head? How are people processing information as we build tools that hopefully support their clinical decisions? But in that scenario, we're using simulation to understand and learn about the system and change the system. I'm wondering, like, abstracting up from the individual learner, what things can you learn from your simulations, either about our medical education system or about how information ought to be presented to trainees? And so to maybe create safer clinical practice environments.
Yeah, thanks. That's a great question. I think it actually ties back into that like existential question there too, because I think what we do see when we think about big groups of learners moving through a simulation, it actually does expose some. Like we recently had a situation where we exposed a gap in some training because we were watching students navigate through a particular clinical scenario, and there was this like systematic issue where they were lacking some organizational structure on how to approach a scenario, and so definitely we could use it from a programmatic standpoint to say, hey, like we really need to buff up this part of the curriculum. The other place that we apply it in the way that you're describing, and it's somewhat on an individual level, but I think over time, a programmatic level is like for our pulmonary critical care fellows, we have them come in, do a simulation with some emergency management and procedures. And we use that to kind of inform how we set up our curriculum. So we have procedural rotations that we might front load for a group of people that need more training in certain types of procedures or more training in certain types of clinical emergency management. So we actually use simulation performance to craft a schedule for people. And so I think that's, I know that we'll talk about that a little bit later as well, using EHR data mining, but I think that the simulation could also similarly be used to say, hey, listen, like we have a situation where a student is like consistently, or group of students is consistently not performing or doesn't seem to have the experience needed. Can we get them that experience in the real world, or futuristically, can we give them that experience? Can we replace that experience or supplement the kind of subpar experience they're having by using simulation embedded into the curriculum, which is really what the larger project that I'm a part of is trying to do, embedding simulation experiences on a regular basis into the curriculum in both non-clinical, preclinical, and clinical experiences.
Yeah, Daria builds on this point, just thinking about, evaluation as evaluating the trainee, evaluating the educational system, evaluating the simulation or educational experience, evaluating the clinical system at large. There's sort of multiple layers of evaluation here. Jesus, student session plus student interaction. And especially in a simulated environment, like there is some evaluation of like, did this environment match reality? Does it,
Yes.
Yeah,
and especially with technology, right, too, because like there is this additional barrier. That's one of the downsides of technology enhanced simulation, is that you have this additional barrier of use of technology. I'll tell you that the students now that we work with, basically, like it took us like, and I'm a kind of tech savvy person, it took me like 35 minutes to set up the headset, we give it to the student, it's like on in 2 seconds. So there definitely is like a much less steep learning curve for them. But it's true that like we need to be looking at like and that's why I think simulation has been such a challenge in the past as a way of just making like actual high stakes assessment decisions. We should not be using it for that at this time point, is my opinion, because there's so much of those interactions that we don't quite understand yet. And so you really do have to look at those like larger sets of data and look at actual evaluation of the simulation experience itself and do lots and lots of pilot testing to make sure that you are drawing the right conclusion from an assessment. And I think that's one of the reasons why we've primarily kept simulation things outside of OSCEs as a formative rather than a summative assessment tool.
A lot to think about. And, in thinking about the sort of more formative assessments, Hannah, can we play Brent's presentation?
Hello, my name is Brent Toma. I am an emergency and trauma physician in Saskatchewan, and thanks very much for inviting me to speak with you today. While playing a role in the development of the competency-based assessment system that we use in emergency medicine in Canada, I got really excited about the potential of the assessment data that we were going to collect. I've gone on to do a lot of work with that data, and that's what I'm going to talk to you about today in this informatics session. My overall goal for this presentation is to inspire you to think about how you can better use your learners' assessment data to inform the development of the people, programs, and systems within your institution. I know that competency-based medical education looks a little bit different south of the border, so I'm going to start off by explaining what our system looks like in Canada, and then demonstrate how we've taken the data coming out of that system and organized it to inform learning, competency committee decision-making, faculty development, and program evaluation, hopefully in less than 10 minutes. So first, a whirlwind tour of Canadian graduate competency-based medical education. Our system is based around entrustable professional activities. For a program like mine, which is, again, emergency medicine, we have 28 EPAs that are arranged across 4 stages of training, which the learner completes sequentially. This is what that might look like. So this is an EPA, our first EPA in our first stage of training, and it is to recognize the unstable or critically ill patient, mobilize the healthcare team and supervisor, and initiate basic life support. Each EPA like this has to be observed a specific number of times overall, and the resident has to be assessed on specific presentations. For example, for this one, that would be things like at least 1 cardiac arrest patient, at least 1 shock patient. And there's also some rules surrounding who can complete the assessment, so whether it's an attending or a senior resident, and some information collected on the context of the assessment. So was it simple? Was it complex? Was it in a kid or an adult? Probably a more relevant distinction for this particular EPA. Then each of those EPAs is rated on an entrustment score based on basically how much you could trust the learner to carry out the tasks on their own. So the scale we use is called the Ottawa Entrustment Score, and it goes from 1, where you had to do all or part of the EPA for them, to 5, where you didn't even need to be there because they knew exactly what they needed to do and they did it without any help. In addition to this, each assessor makes a narrative comment outlining what they saw and what they'd like the residents to do differently to do better in the future. And that's really what most of the assessment contains. They're really quick to fill out. There's a few other tick boxes on things like professionalism and that sort of thing, but really the entrustment score and the narrative are the core of the EPA. And then once we made that assessment system, we mapped them to each of our rotations. So you can see that intensive care has 3 different EPAs mapped to it, and there's different procedures under each one. Toxicology only has 1, but it's got multiple presentations that would need to be seen underneath it. And then our rotations are organized by stage. So our stages are transition to discipline, foundations, core, and transition to practice. And you can see all the different rotations that are in each of those. We expect transition to discipline to take about 3 months, foundations the rest of the first year, core 3 years, and then transition to practice is the last year of our 5-year emergency medicine residency program in Canada. So this is what Canadian graduate medical education CBME assessment program looks like in a nutshell. Our residents go to a rotation, which brings them in contact with patients. Faculty observe those patient observations and they fill out assessments based on those observations, which they feed back to the competence committee, and then that informs the residents' progression through the stages of training to becoming and attending. That's a lot. This includes a lot more assessment data than historically, when we might have, gotten an assessment based on the performance of an entire rotation once or twice a month. That's sort of what our historical system looked like. So what happened when we rolled out this system was that we struggled right here. We had a lot of data, and a lot of it was really good data, but it was really, really difficult to make a lot of sense of it by the competence committee. And really, because it was being presented in various Excel files, and it was tough. Meetings were taking hours. People were spending way too much time organizing data. So we used a design-based research process to basically build a data visualization and analytics system for our data. Design-based research, we take the problem, some theory, some context, we put it into context by kind of interviewing and doing qualitative data collection and analyzing that data. Then we designed a prototype. We evaluated that prototype through more qualitative analysis, and then we redesigned the dashboard over and over and over again with more analyses. And then that resulted in the product that I'll show you right now. So this is what it looks like. I can select a resident. I'll select my fake resident to show data from. You can see that these are the rotations they've done. I can click how many EPAs have been filled out on each block. I can see some test scores, recent EPAs that have been filled out, their progression at each competence committee meeting, which happens every 3 months. And then I can see all of their entrustable professional activities here, some criteria for them. And you can see them mapped on the 5-point entrustment scale, from a 1 down here at the bottom to a 5 again, where that's a good and this is bad down at the bottom. If you want to see the data, you can just click on the table. If you want to see the clinical presentations or other characteristic context, you can highlight them like that. See which ones are kids and how many are adults, that sort of thing. And this is what is used by our residents and our competence committees to see how the residents are progressing through the assessment system. The big things that we found were really, really important, especially with the number of EPAs that we have, were to make sure that the narrative feedback is really accessible within the quantitative graph that we had here. So that was a big focus of this dashboard. We also use this for faculty development purposes. So if I go to the faculty development dashboard, I can pick a rotation and I can pick myself, load my data, and you can see sort of how many EPAs I'm doing relative to the program, my expiry rate, the average EPAs score I have, the number of words per comment in my assessments, how I relate to the number of each EPA that we need in the program. And then this is the big part of it. I can really get down and get kind of granularly into which of our faculty has like an 80% expiry rate on their assessments, because that's not very good. I need to know that so we can go talk to them and do some faculty development. Which of our faculty only give 5 on the entrustment score because they're probably missing something. Our residents are good, but they're not that good. And who's giving me like 5 to 10 words a comment. So if I click on any one of these bars, each bar represents a faculty member, and it will load their profile and tell me how they're doing. Then I can go to our program evaluation dashboard, and it gives me some continuous quality improvement data at the top here. So I can see, for example, how many EPAs we're doing and how many are expired year over year, how we're using our entrustment score year over year, the number of words per comment that has been submitted on each EPA, and then how we're completing EPAs, comparing month to month, year over year. I also can look at this graph, which is my favorite, and we call it our EPA completion distribution, but effectively you can think about it as at what rate are we filling out our EPAs? Are we filling them out too often relative to what our assessment guide requires, or not enough relative to what our assessment guide requires? So by looking at this graph, the math's a little bit complicated, but I can tell you that these are the EPAs down here that we need to be doing more of. And this is the one that we're getting more than enough of based on how we're currently doing assessment. And that can guide our rotation plan and schedule and modifications to our assessment program to make sure all of our residents are getting the experiences that they need to be promoted and move through our program. You can also see how many EPAs are completed on any given rotation that we send our resident to on average, as well as pick a particular EPA and see which rotations it's filled out on. or pick a particular rotation and see which EPA gets filled out. Lastly, we've taken all of this data that we have from all of our programs and put it together in one super dashboard. So you can see, if you look here, we have 13 programs doing competence by design. Everything's anonymized. We've had 14,000, just under that, EPAs completed this year. Those other general metrics at the top. You can compare programs across each other. You can see how the different use of the entrustment scale is happening. So this program gives almost no 1s and 2s, almost all 3, 4s, and 5s are the higher rankings on the entrustment score. You can see how the residents are progressing through their training, how many words each resident is receiving and feedback on their assessments in each program. This one doesn't have all the data in it yet, but resident progress through the 4 stages and see if they're ahead of where they should be or behind. You can kind of identify really quickly on an overview level where your residents are, or which of your programs are struggling with potentially remediation and that sort of thing. And then lastly, this is that same graph that we had on that other one, which looks through each of the 4 stages of training. This is transition to discipline, foundations, core, and transition to practice. And you can see that not everyone's got residents that have moved through this, but you can see the divergence from the assessment program right here and right here. And those would be things we wanted to highlight, because we don't just want to see our programs getting EPAs, but they need to have the residents getting the experiences that they need that match the assessment guide that we've prescribed for that training program. We can also kind of see how each of the programs is getting EPAs filled out over time. So basically what we did, we started with this, trying to make this process work, removing this block right here from the assessments to the competence committee. Then we tried to add in some things because we saw they were necessary. We added in program evaluation data and looking at our data and using it to inform how we're running our program and how we're overseeing all of our programs at my university. And we also using it for faculty development. So when we use our data submitted by our faculty to identify faculty who are excelling and struggling so that we can help them all to improve and improve our program in the process. So happy to discuss and field any questions after this. In general, I hope that provides a useful example of how one might take educational assessment data and digitalize it to coincide with what is needed for various processes and then integrate it into processes like residency assessment, competence committee decisions, faculty development, and program evaluation. Thank you.
I don't know if you can see the comments, but they're, first of all, wow. Seems to be one theme here. I wonder, in terms of one question that both Daria and Yazzie posed is sort of how you think about this procedural skills versus cognitive skills and assessments for those, and do you see differences in the way that they're assessed when you look at this?
So within that's a little bit more of certainly an assessment program system. So we have different EPAs. Some of them really do cognitive tasks. Some of them look at procedural tasks. I think the entrustment score we use really lends itself to the procedural tasks, right? But like, can you put in a central line? Oh, I had to do, well, yes, I had to go in and finish it. It's very unambiguous whether you had to help or not. Whether you needed assistance in more cognitive tasks, I think our faculty certainly struggle a little bit more in trying to put that right rating on there, but we still do have very cognitive EPAs. Like within something like, we have our core, one of our primary EPAs is on basically caring for a critically ill patient. So from our perspective, that is from beginning to end, seeing that patient walk in the door, be sick, get assessed, get a workup, communicate with the family, consult them. Like that's that whole process that we're assessing there. And there might be parts of that they did completely on their own, but there might be a part of that like, maybe should we consult them to ICU right now? Like I'm thinking this, or maybe we should start them on pressors right now. If you're giving those kind of prompts at anywhere during the procedure, we'd expect our faculty to rate them at that level of entrustment. And then in the narrative comments, which is why I say those are so important, that's where they'd say what they struggled with and what they need to do independently or differently overall. And then, I mean, honestly, the dashboard aspects of things is really what we're trying to do there is actually just be able to look at that incredible amount of data and richness of data that we had in a way that's really efficient, because our Excel files that we had before weren't very good. But then when you have all that data, there's so much more that you can do with it. And I think we're just starting to scratch the surface on that. So, yeah.
Well, certainly in this audience, you don't need to tell us about how it feels to be sort of overwhelmed by data and unsure about how best to make meaning and decisions based on all that data. That is certainly very resonant to informaticists. And I'm wondering what process you and your group used to think about, like, these are the things we're going to call out. This is what we need to, this is what really is going to help us make decisions in that meeting in a timely fashion.
Yeah, I mean, for us, there were a couple of things that were for the competence committee meeting, like that first dashboard we showed you, the looking at EPA completion over time and being able to see if they're progressing and most of them are in or the top, like that's just a real quick quantitative visual check. But then the other thing I've seen in a lot of these learning management systems or data visualization tools is they don't link the narrative comment and the quantitative element very well, or they do things that really like drive me nuts, like averaging the EPAs over time, which like they're supposed to be improving over time. Giving an average punishes someone for getting a formative EPA early on when they might have been getting fives for their or 5 out of 5 at the top of our investment score over time. So that was the biggest thing. The other thing that I found surprising in our EPA-based system, it actually seems to be relatively predictive how many EPAs the resident is getting. Like we had that graph showing how many they got on each rotation at the top of the screen there. The residents who are struggling often don't get as much feedback or EPAs. They often maybe are a little more hesitant to ask for them because they know they didn't do as well in them. Or they're just not seeking feedback as much because they have other personal or other struggles going on. So we would even see residents that would be doing well. One I remember specifically had some interpersonal challenges, relationship issues, outside of medicine environment, and their EPA acquisition just fell off the map. And you're like, oh, so that's where that happened right there, and you can map it back, and it's kind of cool. So some of the things that we're looking at in the future are how can we so we meet every 3 months and look at this data. Could we use a machine learning model to identify patterns that are predictive of residents that are struggling and have that be flagged? That's a little bit like Minority Report-ish and potentially scary, and I think that's the immediate reaction that we get. But it's not saying, it's just, to me, I compare it to the ECG. You look at an ECG and the ECG at the top says, oh, maybe they're having a heart attack, or maybe they're having this other whatever disease. I can't think of a PEDS ECG element, but you're going to look at that a little more closely, and you might not come to the same conclusion, but it's nice for you to be able to see that earlier rather than looking at them months later and realizing there's been a problem for the last several months that you didn't identify. So I think that's one of the ways we're hoping to use this increasing amount of data. Again, we're getting thousands and thousands of data points. It's not big data, but it's bigger data than we're used to in medical education, certainly.
And we're going to talk, I think, in a minute now, we'll hear from Jonathan sort of about expanding that even further to think about clinical practice and how we can incorporate practice into how we understand what learners are doing and learning. Hannah?
Hi, everyone. I'm delighted to be here today. My name is Jonathan Roan, and I am an Associate Chief Medical Information Officer at Boston Children's Hospital, as well as the Program Director for our Clinical Informatics Fellowship. I'm really excited to be here today. I've really enjoyed the speakers thus far, both today and the prior sessions in the colloquium, and I hope we can use this time to build on what we've already learned. So I'm going to talk today about your trainees in the EHR, using data to support learner assessment. I have no financial disclosures, but I will just say that all of the work presented here today has been done in collaboration with really outstanding pediatric trainees, as well as with our GME data analysts here below. Some of them have moved on to bigger and better things, but they are all really crucial to the work that's being presented today. So I wanted to start by just, by way of background, talking about our ACGME Common program requirements, which many of you, I'm sure, are familiar with. And a reminder that at least as of 2014, 2015, when I started getting into this work, the ACGME was surveying residents annually, and still are, and asking them if they were receiving data on their practice habits. And we had been doing this to some extent, but in a very limited capacity. And so really in looking at the program requirements around trainee evaluation, quality metrics, program evaluation, and resident well-being, you could imagine that we could be using data across the board here. But most of, I think, traditionally what we use is subjective assessments at the end of a rotation. And really what we're setting out to do is use our EHR data to really develop some more objective assessments, not to replace those subjective assessments, but really just to augment the assessment. And we'll talk about each of these as we go along. So as I said, it started around 2014, 2015 with Jonathan Levin, who was a pediatric resident at the time. And he really was just interested in what his experience as a trainee was compared to his colleagues. And so in starting to think about how we could objectively assess trainee evaluation, we came up with this idea to just a proof of concept to see, can we use the electronic health record data to visualize our trainees' clinical exposure. And we took our new enterprise data warehouse, which puts a lot of clinical data all in one place for us to query and has a nice web-based interface that even I was able to figure out. And we created this dashboard, and we built it basically off of the number of encounters where trainees were documenting a note. So that could have been a visit to the clinic where they created a visit note, an emergency department visit where they contributed to a note, or any inpatient documentation where they contributed to a note. And each inpatient encounter, the patient's encounter, that entire stay, would count, as a 1 in that, similar to the ambulatory and ED encounters. And we looked at the diagnoses that were associated with those encounters. And so you can see in this dashboard on the left side, you can filter by who the trainee was, in this case, Dr. Levin, what type of notes you were interested in, or what venue of care. And if you wanted to, here we're seeing all of the data from, I think it was October to June, but you could sort by diagnosis, you could sort by the patient's age at the time of visit, or by their medical record number if you actually wanted to look at a specific patient. And the heat map at the top just displays, based on the size of the box, the number of encounters you had with that diagnosis. You can see in inpatient, dehydration was the most common diagnosis encountered. Dr. Levin was in our pulmonary neonatal follow-up clinic, and so his outpatient encounters mostly had to do with BPD and short stature. And at the bottom, you can see a little more detail on the number of encounters across venues of care, as well as the diagnoses and the types of patients. And this had a companion aggregate dashboard where you could compare your experience to the median experience of trainees in your class. And our thought was this could be provided to a trainee, somebody could go through it with them, or to a program director to start getting a sense of what the trainee has seen and maybe where the gaps are. Over the years, this has grown, and our GME data analysts have helped us create numerous reports like this. We now have 20 that are actively in flight tracking trainee metrics. And on the left side here, you can see some of the different types of metrics people are tracking. Most of them have to do with clinical volume, how many appointments you had, how many orders you placed. But we do have a few that are tracking, I think, getting more towards that quality assessment. Diagnosis exposure, are you competent at taking care of patients with cystic fibrosis? Well, here's all the patients with cystic fibrosis you've had. And then really specific quality metrics in a few instances. And so you can see time to note completion, percent of patients with diazepam prescription, that's for our neurology colleagues, percent of patients with a flu shot. The right just shows the breadth of programs that are using these metrics, and you can see it includes a host of pediatric subspecialties, but a number of surgical colleagues as well and others. Another project that I think highlights how we can use the EHR to assess quality was a project that Julie Yarwan did when she was a resident. Julie has since gone on to a pediatric hospital medicine fellowship in Texas, but is returning to do clinical informatics next year. And she identified an order set that she thought was confusing and probably leading to errors. And again, used our data warehouse to identify patients where platelets were ordered. We identified whether the amount transfused fit into the category based on that patient's weight, or whether they were being under or over transfused. And sure enough, she found that there were a significantly more number of errors when residents used this order set compared to another order set that was a little more streamlined. And really elegantly documented that when we corrected that order set, when we adjusted it, that the errors went down. And so just a nice way of showing how we can really get at quality and are people using the tools that we're giving them appropriately. Another example, and this one is hot off the presses actually, just in Press and Hospital Pediatrics by Alexandra Giannakopoulos. This study, Ali wanted to look at pediatric intern clinical exposure during the pandemic. And so she looked at a 3-month period in 2019 versus a similar period during 2020. And really what she was able to document, again, based on the patient seen either by resident note completion or orders entered, she was really able to document a shift in the types of diagnoses that our trainees were being exposed to. And I suppose we could drill down to the individual trainee and use this as a trainee evaluation, but to me, it was really a nice example of how we can actually use these tools to evaluate our program and how our program is changing over time and where new gaps may have been created and things we may need to address. Moving on to works in progress. So this is really exciting work coming that we're just finishing data collection on this project right now, but the ACGME requires programs to pay attention to scheduling, work intensity, and work compression, and they don't really define what work intensity is. So we created a definition that we thought made sense based on patient factors that might make a workday intense, trainee factors, other things, and figured that if we divided that over time, we might be able to generate a score for work intensity. So we have a subcommittee working on this right now. My slides are out of control. And the subcommittee identified a whole host of factors, probably 40 or 50 things that we might be able to measure. And we found which ones we could measure in the EHR. And so we've been surveying our residents now almost for 4 months, asking them, what was today's workload intensity like? Was it so low that you were bored? Was it somewhere in the middle? Or was it so high that you were exasperated? And this is a continuous scale that can slide up and down. And so our hope is to use the data in the EHR to then do a regression analysis and see whether we can actually model workload intensity. I'm a bit low on time, so I won't go into all these in details, but needless to say, there are challenges and limitations to this data, and in particular, assessing whether a given trainee sort of had ownership over a patient. And Dr. Zorenstein and Mai and others at CHOP I know have done a lot of great work around that. But also merging disparate data sets. And at the end of the day, I think it's about how we make this data actionable. And I'm going to stop there for the sake of time, but obviously happy to take any questions. Happy to take any questions and looking forward to the discussion. Thank you.
Thank you so much. You know, so often what we measure drives the things that we improve on. And I'm wondering how you, as an informaticist and a medical educator, think about that, Jonathan. You know, things that are easy to measure, are those also the things that we have an ability to measure? How do we make sure that the things we're reporting are actually the things that we are most important for us to improve on?
Yeah, so that's a great question, and a challenging one, because certainly in the EHR data, there's plenty of things we can look at. To me, one of the most important things I think about is, you know, what's going to be actionable, and that was why even with that first proof of concept, you know, we were constantly thinking, okay, so what is anybody going to do with this list of diagnoses? And so this idea that, you know, really the next step might be finding the gaps and finding what you're not hitting to help inform either, you know, self-study or, you know, getting a resident into clinic so they can get some more exposure. I think the other challenge we've really had is, you know, how do you attribute clinical decision making to a trainee based on something in the EHR, particularly in the ED and ambulatory. It's a little easier, although still certainly if you've got a trainee and an attending, you don't know what conversation happened. Maybe the trainee had some crazy plan and the attending righted the ship, and that's why the outcome is what it is in the EHR. In the inpatient space, it's even more complex, where you have a whole team of people, and you know, your pharmacist is giving input, and your social worker, and all these different people. I think natural language processing might help us with that at some point. You could imagine, right? The overnight resident probably has less input from attending than other people on what they're writing, and so, you know, pulling out that data might give us a better idea of what that person is thinking. But it's challenging to get at that level of assessment from this data.
Yeah, and I think that's a really nice point to end on, because I think that is an area where you can use, for instance, simulation, or you know, you can use some evaluations to build a holistic way of looking at what trainees are doing. So it is helpful to think about sort of where each of these ways of evaluating learning, you know, what they offer, and how they could complement each other. I'm looking at the chat. Dr. Callahan asks, have you used the electronic health record to define who should evaluate? Can you map who's shared patients in a reliable and repeated way, and therefore direct evaluations to those faculty to evaluate trainees, and to those trainees most appropriate to evaluate faculty? He notes that we've tried to do this among faculty for peer-based clinical assessments with varying degrees of success at Penn and CHOP, depending on the institution, specialty, inpatient versus outpatient setting.
Yeah, I didn't dwell on it, but one of those reports in flight for pediatric urology is actually looking at pairs of a trainee and an attending to basically keep track of how many patients those people have seen together, so that you can look across your faculty or across your trainees and see, you know, who's seen the most patients with whom, and which patients, what diagnoses, that sort of thing. I think it's a great point. I think somebody also had mentioned, you know, the subjectiveness of evaluations. We've got to get to a point where we're able to bring more objectivity, and it may be that we have to do some comparisons between those two data sets and get a sense of what's real versus what's bias.
Brent, I want to ask the same question to you. Are there ways for you to link trainee and faculty relationships in your data?
So it's a little bit different for us because the faculty is the person who filled out the assessment on our learners in our system, so it's educational data. So it's very, very, very linked. We have not pulled any clinical data into our system yet. That's something we'd love to be able to do, but just haven't gotten there yet. So look forward to learning more from Jonathan and his group as to how we did that. It's tough in our system, but yeah. So no, we have our learner linked things we want to look at. Like there was a question about bias earlier. We want to look at like more of those types of things in assessment. Like if you've in our system, in our hospital, in our specialty, what kinds of biases are there and how do they show up in our assessment data when you have different residents and faculty linked together? That's more how we look at it, but again, we haven't explored the clinical context or the outcomes. I'd love to tie those assessments to specific patient encounters and also look at like things like Dan has looked at like resident-specific quality metrics that we'd pull into that would eventually explore that aspect.
And Kate, is your data linked at all? Can you look at how people perform, like how people perform in their evaluations? In their simulators?
Yeah, we're not there yet. I do want to say one thing about kind of a separate part of my life where I do look at bias and evaluation, gender and racial bias, and I think, man, I'm so excited about what you all are doing. I think it's such an interesting and such a useful and important thing. One of the things that we have done is in our research group is natural language processing evaluation of narrative data of faculty and now more recently of learners to look for gender-based differences in language use, and we're actually in the process now of giving people using natural language processing to actually identify like not related to gender specifically, but like good and bad evaluations, like helpful and not helpful evaluations, and eventually looking to give people either scores about how they're doing so that from a faculty development standpoint, they can improve upon their evaluations, or in its kind of purest sense, idealist sense, actually like a real-time natural language processing that would do suggestions such that if someone wrote like needs to read more, they would say, hey, I think you were trying to talk about their medical knowledge. Maybe we want to say something like this or that, something more specific. So such interesting work, and I've learned so much from the other panelists today. So very exciting, and thanks for putting it together. You're muted.
Man, I was just thanking you guys and saying that it's about 5 past the hour. Our final talk is going to be thinking about some of this convergence. So I hope that our panelists, but also our participants, can make it to that wrap-up session on May 20th. And the link to this presentation will be posted on the DBHI website. I'm going to revisit it before that session and revisit some of this chat also to think about some of these questions that have come up and how we can pick them back up. So thank you, guys.
Thanks for having us.
Thank you so much. This was terrific.
We're also going to just check your email. We're also going to be sending out a survey within the next week to look at how people would like to continue to stay engaged in this, in this work.
That would be great because I'm emailing Caitlin and Brent right after this.
Awesome.
Thank you all so much.